So today we're going to talk about volume and surface area. And in 8th grade, I really think what we need to be the most familiar with is how to use a formula and where to tell the parts of a shape are so that we can plug up those numbers into a formula. And so this state assessment test that we take gives us a formula sheet, and I'm going to just briefly show a little bit about it. This is the resource page for the 8th grade test, and you can see that they're only going to give you some complicated formulas, and that you really then have to know what each one of those are. And so on my personal copy, and the copy that I would suggest you make, as we learn things, we should probably annotate our formula sheet so that you can go ahead and understand where all those parts come. The 8th grade material is really expecting that you know the 7th grade material and where all the parts are. And so if I give you an area formula, those would be these shapes, and those would be where I would find the base and the height. And that a square is an S to the S, and that the triangle is base times height, and so on for trapezoids and circles. And they really expect you to be able to know the difference between a radius and a diameter in a circle and how to go from one to the other. That is the 7th grade material that they're expecting you already to have memorized. And so they've put it on here, but they've only used the formula. They haven't reminded you of the parts or where those are found. So they're expecting you to remember that from 7th grade. And so what we're going to do today is we're going to talk a little bit about specific formulas and kind of where the parts are. And so we're going to start with some easy shapes such as a cube and a pyramid, rectangular prism, or box as I like to call them. And what I have done is I have drawn the net for you. So when we talk about surface area, you can kind of get a visual for what we're looking for. So when we are doing the cube, the formula for that is really just going to be, you only have one variable, and it's a 3-dimensional item, and so it's just the s to the 3rd power cubed, because it's s times s times s. So if you had to have those s's in multiple places, it is the height, it is the base, and it is the length. So it has 3 s's, so it's s to the 3rd power. Now, when you look at it in a 2-dimensional object, remember area is 2-dimensional, so that means I'm only going to have something to the 2nd power. So really I'm just going to count up. There's 1, 2, 3, 4, 5, 6 squares, so it's s to the 2nd power times 6, because what we're using is the formula for a square that we know from 7th grade, and we're just going to multiply that by 6. And so just a reminder, remember it is s squared, and they would tell me that. They do not, however, tell you the area for the volume formula. They just give you the capital B, which means the area of the base. So this would be what we would come up with for that, or you could use the box method, which is length times width times height. Then you know that they're all the same number. So if I were to give you, let's say this was 5, you would just do 5 to the 3rd power, and you would be done. So the other easy one is the regular, like, shoebox shape, Kleenex box, whatever you want to think about it. It is the length times the width times the height. You can use base if you like that better. Some people like to use a little b, but it gets confusing. So I recommend using length times width times height. And so you're finished when you multiply those. You just put the unit to the 3rd power, and it's complete. But when you think about the surface area formula, we practice these in 7th grade. You have 2 that are this size, you have 2 that are this size, and you have 2 that are this size. So you have 2 sets of pairs. And so the way we work that is, it is the length times the width, plus the width times the height, plus the height times the length. So essentially a pair. This pair, and then the last pair. And then we add those all up, and we take the whole thing times 2, because you actually have 2 of each. You can't just do 1, 1, and 1 and be done. You need to double that. So that's what our formula is going to look like for that. And if you don't like it with the parentheses, you are more than welcome to do 2 length times width plus 2 width times height plus 2 height times length. So you have 2 of each. Now we're going to talk about the next most common shape that you're going to get is a cylinder. And so let me write this because it kind of got cut off my paper just a little bit. So we have a cylinder. This is where the capital B comes into place. And so I want you to remember that this is not the base. The capital B means the area of the base. So it's the area of the base. And in our case, we know that the area formula of the base is a circle. See, we have circles. So the formula for a circle, if we don't remember, is pi r squared. So this formula right here is pi r squared, and then we have it times the height. So this is the capital B part, and then we're multiplying it by the height. So if I were to give you numbers, what normally ends up happening is somebody gives you the diameter instead. So they come over here and they draw it, and then they say this is 10. And then people get in a hurry and they do pi times 10 squared times h, and that is not what happens here. So let's say this was 10 going across and the height is 12. So if I were going to do this particular problem as an example, I would do pi, half of 10 is 5 squared times 12. And so I would work this math problem out to get an answer. So remember, if this is the diameter all the way across, I have to remember what I am doing, and I have to go ahead and change that to the radius. So again, if you need to see that picture, the radius is halfway across, and the diameter is all the way across. So to go backwards, you just divide it by 2. Now I've tried to draw, you know my drawing skills are limited, so one circle looks pretty good, and then I don't know what happened over here. But the surface area formula, if you were going to cover it with paper going all the way around the outside, you would end up with a circle on the top and a circle on the bottom, and then you'd have the paper that wraps all the way around it. And so the tricky part is figuring out how to do this rectangle piece, because the circle formula is easy. It's just pi r squared that we used up above, and then we have 2 of them. And they've given me the radius in this case. In our case, it would have been 5. But what we're going to think about is this piece right here going around the circle. If you were to wrap it around, let's say a pop can, if you were to wrap it around, this piece right here is the circumference, and that is where this piece right here comes. So it's going to wrap all the way around, and that's going to be the circumference. So again, this would be the circumference formula times the height. So it looks a little funky when I put a capital C in there, and we're going to obviously add those 2 pieces together. But we know that the formula for the circumference is pi times the diameter, or if you like to use the radius number, again, it would be pi times 2r times h. So 2r, remember, is the same as d. And so when I write it all out, it looks like this. 2 pi r squared plus 2 pi r h. So again, the formulas aren't bad. What we have to think about is where they come from in the picture. So again, I've only given you 2 numbers. So if I gave you that d equals 10 up here, in case you still can't read my handwriting, and the h equals 12, the first thing you need to do is figure that r equals 5. And now you can plug it in the formula down here. You would just take 2 times 3.14 times 5 squared plus 3.14 times 2 times 5 times, in this case, the height is 12. It's the first time I need that. And then at this point, it's just calculator work. And that's not the interesting part of the problem. Just remember that we're in area, so it would be whatever we have. Like, let's say this is inches. This would be inches squared when we worked it out. Where up here, I would have inches to the 3rd power because it's a 3-dimensional object. It cannot lay flat like our net does. All right, so now let's talk a little bit about some other shapes that happen rather frequently. We have what's considered a cone. It's another very common, and it's very similar to the formula for a prism. A prism or a solid is an item that is the same size on the top and the bottom. And when I add in the word pyramid or cone, now we want 1/3 of it. So it's the formula for all of them. And you'll notice, again, I'll just show you on our cheat sheet that the state assessment test is going to let you. Anytime you have a pyramid or a cone, it's going to be 1/3 the area of the base times the height. So if we already know the cylinder formula, it's the same thing. We're just going to divide it by 3. And so you can either write it with the fraction out front, or my personal preference would be to write it this way. We know this, again, is pi r squared for the area of the circle times the height, and then I just write it divided by 3. That is the same as putting the 1/3 out front. Now notice we don't need the slant height yet when we're looking at the volume. We don't need slant height, and so we're looking for the surface area. And different books use different things for slant height. Some of them use an S and an L together. Some of them just use an L. Some people get confused when it's length and it's not really the length, but what it is the distance from the top of the pyramid to the outer edge of the cone. And so we call that the slant height. And so what we have is a circle with a triangle where the slant height is involved. And so that's the parts that we're going to look at. And so when we look at that formula there, we are going to start with the circle, pi r squared, because that's the area formula for the circle. And then when we work on the next part, the formula for a triangle is 1/2 the base times the height. And so we know the base as part of the circumference. And so it gets a little tricky because our circumference formula up here, remember, was pi times 2 times r, but then we're taking half of it. And so the formula that the book would look up looks like this: 1/2 2 pi r, and then in our case the height would be the centerpiece right there. And so we would have the height, which would in our case would be the slant height, because this height is the height of the volume and it's not actually touching the slant height. So the slant height is the height, and so I'm going to put a capital L. And so then when I work this out, it becomes pi r squared plus pi r L. And so that's what we're going to work at. Okay. And again, it's mainly about knowing the formula, looking the formula up, and plugging in all the parts. Spheres are fairly simple. There's only one number when I give you the sphere, and so you just have to pay attention to whether I've given you the radius or I've given you the diameter. Both formulas are interested in the radius, so what normally happens if I'm trying to be nice and easy for you is I go ahead and I just give you the radius. But most of the state assessment and ACT that you'll be seeing later, those are going to then give you the diameter just to make sure. So I'm going to do a quick little example over here, unlike some of the others. And I'm going to tell you that in this case, the diameter is 20. Which means before I can get started, the first thing I need to do is, so if I tell you going all the way across my circle here is 20, then I would have to find the radius. So I would have a radius of 10. And then you would just take 10 times 10 times 10 times pi times 4/3, and you'd be done. Or if you were doing square root, or surface area, excuse me, you would do 10 squared times pi times 4. So again, they're fairly simple, fairly straightforward, but you just have to know where to put this number in, and it would go right there. All right, so now let's look at the trickiest ones that you might see. And those are the pyramids, or the ones that are actually prisms. So this is a prism. It is a solid on the top, whereas this one is a pyramid, and it has a point at the top. And so I've identified all the parts here. The formulas for volume are very straightforward. It is, again, capital B times H, or capital B times H divided by 3 when it's a pyramid and comes to a point. So the formula seems really easy, but again, you have to know what the area of the base is. It's just not one number. So if I were to give you an example here, let's say, for instance, I gave you a triangle, and it was, let's say it's a 4 by 10, so the height is 4, the base here is 10, and then this dot, 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 that height right there that I'm looking for, let's say it's only 5. And so the formula for the triangle at the bottom would be a height of 5 and a base of 10. So it would be 5 times 10 divided by 2 times our height of 4. And then we would work it out like that. So that would end up being 100. So it's not very difficult, but it is something to think about. And so if we think about that over here, the same thing happens. I have a 5 for the height, and we have this number is 10, correct? So we have that there. And then our piece here is 4. So you have to think about unwrapping the whole piece. And so this ends up making this one also 5. So we end up having we need to know more things to do the surface area, because I would need to know like this piece and I would need to know this piece. So as we work those pieces out, let's say this one is also 5 and let's say this one is 7. So then I would have let me try this one as 5 and this one is 7. Just because my picture makes a little more sense that way. So you have to find the area of this rectangle, you have to find the area of this rectangle, you have to find the area of this rectangle, and then you have to do 2 of these bases, so because there's one on the bottom and one on the top. And so what ends up happening is there's no good formula for this. You're literally just working out all the parts, and so this is where people get all tripped up, because there's not a great formula for that. You have to go ahead and figure out that. They give you a shortcut formula for that when they are working that, but most people struggle with where that is coming from. So let me just show it, because they're talking about it's the perimeter times the height, which means you would have to find up the perimeter all the way around the outside. So that would be 5 plus 7 plus the 10, and that would take care of all of these here in the middle. So again, if you like short formulas, then you're going to have to know where all the parts are. So again, I'm going to show that formula. You would have the 2 bases plus the perimeter times the height. So that's the short formula, and that's all they're going to give me on the state assessment test. But that's coming from here where I'm doing the perimeter, which is this, this, and this. So I'm essentially taking care of all of those at once and making it one long rectangle times the height of 4. So this would just be 22 times 4. And then we would add to that the base times the height, which in our case was 5 times 10. And because we don't have one of them, we have 2 of them, I won't go ahead and divide. And so that would end up being another 50. And so we would work this out and we would have whatever 50 plus 88 is. And that would be my answer. And like I said, those are a little bit trickier, but not too bad. And then the last thing that we have here is a pyramid. So what we're going to do here is we're going to, again, do the formula. It's the area of the base, which in our case is a nice, easy rectangle. And so we just do the length times the width divided by 3, and then we take it times the height. Notice that the height that we're talking about is the one in the middle, and I've clearly identified that. When we do the surface area, again, we're going to have 4 triangles and a square in the bottom. And we already know this, the square, or in this case, it might be a rectangle. In that case, this one and this one would be the same size triangle, and this one would be the same size triangle. So again, you have to know how to find each one. And so the slant height down the center is going to be the same. All of these are going to be the slant height. So our slant height would be coming from this outside number. So you have to know where that comes from. So if I draw a quick one right there like this, and I draw my thing, and I tell you that the slant height is 10, and I tell you its regular height is only 8, and that it is, let's say it's 6 by 4. So again, you can't really tell that the height there works very good, so I'm going to mark them. But if I did mark it, the inside piece would be 8, and this piece on the outside would be the 10. So that's where those would come from. And again, I'm just going to work them out. I would do the area of the base, which in our case is a rectangle, which would be 4 times 6. So that's easy. And then I would do the 2 triangles that have the base of 4. So I would have 4 times the slant height of 10 divided by 2. And I'm going to multiply that by 2 because there's 2 of them. And then again, I would do the other 2 triangles, which would be 2 times the base of 6. So I have 6 times 10 divided by 2. And we will work that all out. So we would end up with 24 here. These would cancel out, and I would have 40 for the 2 triangles, and here I would have another 60. And so I'd end up with 124 as my answer. And if I were labeling this, it would again be to the 2nd power. So let's say it's units or inches to the 2nd power. All right, I know this movie was super long, but I wanted to make sure that you had a place to go back and look at them. I definitely do not expect everybody to have watched the entire 20 minutes all the way through. But what I do hope that you find out is that as you are looking through the formulas, you can fast forward and get to the parts that you really need. So again, great job today. Thanks.